Today's video will explain the bottom-up development process. Hello, I'm James Helfrich. We design top-down, but we develop code bottom-up. Well, what's the best way to do that? Well, it's a little bit more complicated than you may think. This video will demonstrate that process. We'll start by discussing the difference between top-down and bottom-up. Top-down is the process of working from the most general and large down to the most detailed and specific, and bottom-up is going the other way around. Well, which is better? Well, it really kind of depends upon what you're working on. For an example, requirement solicitation, that's the process of figuring out what the client needs. Do we do top-down or bottom-up? The best answer there is however the client thinks. Some people intrinsically think top-down, and if that's the case, then ask them questions about the project top-down, ask them about very general things about what it's supposed to do and its capabilities, and finally work down to the specific and minutiae features. Well, other people really are detail-oriented. They care more about how the detailed processes rather than the big picture. In that case, begin asking them questions bottom up and have them slowly work up to the larger design. In either case, the requirement solicitator needs to be good at working both top-down and bottom-up and accommodating the needs of the client. Now, when we design, we always design top-down. Now, by analogy, let's say we're going to design a car. We don't start with first, I want to use this bolt, and then based on this bolt, I will want to make this water pump, and based on this water pump, I want to make this engine, and based on this engine, then I'll figure out what kind of car it goes in. Well, no one does that. We always go the opposite way. We always start with something very general. What are the needs of this particular car? Then we figure out what kind of engine that car will need. Then we figure out what kind of water pump that engine will need. Then we figure out what kind of bolt we'll need in that water pump. So we always go top down on the design process. Now, development is actually the opposite. We don't want to start by putting the car together before the pieces are done. No, we start with the most specific things and test it. I'm going to start with that bolt. I'm going to build it, and then I'm going to test it. Then I'm going to take that water pump that the bolt is used in, and I'm going to build it and design it, and then I'm going to test it, and then move up and up and up. And the last thing I do is assemble the car, and the last thing I do is test it. And so development and testing go hand in hand. We always work from the bottom up, the most specific things, get confidence in that particular product that we just built and we tested before we assemble it into bigger things. This is especially important with testing. If I have a car and it doesn't work quite right, where's the problem? Well, it could be anywhere. It could be any of the pieces in the car that is causing the malfunction. It's very difficult to get to the source of the problem when you start with a large product. But now, on the other hand, let's say I'm just working on the water pump. If I test that water pump and it doesn't work, well, the problem is in the water pump. Figuring out the source of the problem is much easier when I start really small. Now, once I know that water pump is fully functional and everything works the way it's supposed to, then I can go up to the engine. And once all the engine pieces are fully tested, then I can test the engine together. And therefore, any bugs I will have will be the interaction between the components, not the components themselves. So we always test from the smallest possible thing to the largest possible thing. Okay, let's take a detailed walk through the development process. We're going to start by designing the program. And we're going to design the program as much as we can, realizing we will never again be as ignorant about the product as we are when we start. So we're going to try to figure out what components we need, what kind of functions, what kind of classes, whatever. We're going to do the best we can to design it down. Then we're going to stub the program. We're going to make placeholders for everything we've designed. We're going to make stubs for all the functions, placeholders for all the classes. Every different piece, we're going to make a placeholder for it. So all the different interconnections are represented, but none of the functionality is there yet. Now we're going to select a single function. Are we done yet? Have we worked through everything we know about yet? If the answer is yes, I got to ask you, is the entire product finished? Because when we implemented a few functions, it may turn out that there are more things we have not yet designed. If that's the case, we're going to go through and do another iteration of the design process and try to get all the ideas that we know about now that we're more knowledgeable about the product into the design. And of course, if we built everything that is we know about and there's nothing more to know about, then we're finished. But more likely, that function that we selected, that little placeholder in the data flow diagram or the structure chart, is not yet fully implemented. In that case, we're going to review the design. Why are we going to review it? Well, it might be that our knowledge of the product has changed since we first did our initial draft a while ago. It might be that we know more about the parameters coming in or the required functionality, whatever. We just want to make sure that our draft of that design is most current before we begin the actual coding. So now I'm going to implement that in my language of choice. And I'm going to test it. I want to thoroughly test that function or class to make sure that it works exactly as I expect. I'm going to, at very least, manually run through the code a few times with an ad hoc driver. Probably, I'm going to make some automation with some asserts to make sure that all the test cases I can think of at this point in time are fully functional. But better yet, I'm going to make a full-on unit test suite. Now, does it work? If the answer is no, then implement it again. Usually the best practice is to undo off my previous implementation and then add some new functionality, because my second draft through, I'll probably be more knowledgeable than my first draft. However, sometimes it's just a minor bug I can fix and I can just tweak the code. Whatever the case, I want to keep going through, implement, test, implement, test, implement, test, until every single test case that I know about works perfectly. And therefore, this function or class is fully functional according to my knowledge of the product. Now, if it does work, then I go back and select the next function or class that is part of the existing design. And then I'll go through the process again. I'm going to go through and everything that I know about is fully implemented and tested, and then go back to my more section and say, you know what? There's actually a few things that I have to build yet. There's some functionality I forgot about or did not fully anticipate, and I will work through the design again and again and again. This is described in detail in the bottom-up development process section of the Bottom-Up chapter of the software design textbook.